Hello champions, Miss Tilly here. We're going to do a quick review of the rock cycle and the rocks that are in it and the processes that occur. So before we start talking about our rocks, let's talk a little bit about our minerals. Remember that minerals are naturally occurring inorganic solids with a definite chemical composition and orderly arrangement of atoms, meaning they have a crystal structure to them. All minerals are rocks, but not all rocks are minerals, because rocks are kind of like a mineral cookie in a way. They have a combination of minerals and other substances in them. Remember that some elements by themselves can be considered minerals because they have those characteristics. They're naturally occurring inorganic solids with a definite chemical composition and orderly arrangement of atoms. I'm going to show you some of our minerals here. This one is magnetite. It has a specific property of being magnetic. This one is sulfur. We have some fluorite. We have some gypsum in the back there, I believe. Galena. There's some mica. We have some copper ore, some feldspar, and some quartz. Those are some of our minerals. Now, remember when we talked about rocks? Rocks are a combination of minerals and other materials. Our first category of rocks that we talked about were our igneous rocks. These are rocks that have formed from magma or lava that has cooled over time. We have categories of igneous rocks based on where they form. Extrusive igneous rocks form from lava that has cooled quickly, or magma, near the surface or on the surface. We have our volcanic glasses like obsidian, pumice, and scoria that cool very quickly, and they form no mineral crystals to them. They cool so quickly they don't form mineral crystals. They're called volcanic glasses. And in pumice and scoria, you can see some of those air bubbles that have formed due to the gases that have escaped. Now, we also have other extrusive rocks that have very small mineral crystals to them. Rocks like rhyolite have very small mineral crystals to them, and those are extrusive igneous rocks. They form at the surface from magma or lava that cools very quickly. Now, our intrusive igneous rocks are the rocks that form inside the earth from magma that cools slowly. They tend to have larger mineral crystals. Rocks like granite can form in this way, where they have larger mineral crystals and they form from magma that cools slowly inside the earth. These are our igneous rocks. Remember that sedimentary rocks form from sediments. Sediments form due to processes like weathering and erosion. Weathering breaks down the rock, and erosion moves those sediments from place to place. Those sediments can get deposited and then cemented and compacted together. So sedimentary rocks are actually rocks that form from the sediments that have cemented and compacted together after sediments have formed. We have three main categories of sedimentary rocks. They are organic sedimentary rocks that have remains of once living things in them. Examples include coal, petrified wood, and rocks like coquina that has shells and sand that are cemented and compacted together. Another type is a clastic sedimentary rock, and rocks like shale, rocks like sandstone are examples of clastic sedimentary rocks. I wanted to say slate instead of shale, but shale is a sedimentary rock. Slate is a metamorphic rock. These are rocks that are just sediments that have been cemented and compacted together. Our third type of sedimentary rock are chemical sedimentary rocks. These are rocks that form from sediments that have precipitated out of a solution, or the water has evaporated off and left behind the rock, the mineral that has formed. So precipitate means falls out in solid form. So these have sediments that have come out of a solution. Examples are like halite, which is natural salt, chert or flint. We have some calcite there. Our geodes that might be formed from calcite or quartz are examples of chemical sedimentary rocks. Our third type of rock is our metamorphic rocks. And these are rocks that have changed due to extreme heat and pressure. They could have been igneous rocks or sedimentary rocks or other metamorphic rocks, but they've changed over time due to extreme heat and pressure. When we talk about metamorphic rocks, we're talking about their textures also. Are they foliated? Did the minerals melt and rearrange and form layers? Things like slate, schist, and gneiss are examples of foliated metamorphic rocks. The minerals have melted and rearranged into layers due to extreme heat and pressure. Now, the entire rock did not melt to form magma. If that had happened, we would end up with an igneous rock that might have formed, but the minerals in it have melted and rearranged to form layers in a foliated metamorphic rocks. Other metamorphic rocks are non-foliated metamorphic rocks. Rocks like marble and quartzite are examples of non-foliated metamorphic rocks. Their minerals melt and rearrange, but they don't form layers. Rocks like marble can originate from sedimentary rocks like limestone, and rocks like quartzite can originate from sedimentary rocks like sandstone. Let's find some sandstone. Right there, sandstone. Rocks like gneiss can originate from different types of rocks. They can originate from slate and shale. They can originate from granite. Here's some examples of granite. So they can originate from metamorphic rocks. They can originate from sedimentary rocks or originate from igneous rocks. And there's different levels of metamorphism based on how much extreme heat and pressure there is. So some of the processes that we deal with in the rock cycle include those processes of weathering and erosion, those processes of compaction and cementation to form the sedimentary rocks, melting and cooling to form magma and lava and to form those igneous rocks, and extreme heat and pressure to form those metamorphic rocks. Now, it's a continuous cycle. It doesn't end. Rocks can stay a certain type of rock for a long time. And sometimes it takes a long time for rocks to change into different types of rocks, but the matter is not created or destroyed. The minerals don't go away. The elements don't go away. They can change forms. They can change into different types of rocks, but those processes are going to not destroy the matter. So I hope this gives you a good review of the rock cycle. If you have questions, please email me. I hope you're having a great day.